Good afternoon. I'm Don Seddon, President of IQware Solutions. I'd like to welcome you and thank you for joining us this afternoon. I think you're going to enjoy the presentation and learn quite a bit about cybersecurity, what the issues are, and how to solve some of those issues. We're very grateful that Oracle is here to help us with this. And I want to let you know that the presentation will be available online afterwards on our website, as well as the video next week, so you can download that. There'll be a lot of information presented by Dr. Belovich that, rather than try and take notes, you'll be able to download the entire presentation. With that, I mentioned Oracle earlier. I'd like to hand this over to Jim Matheson from Oracle to tell us about our partnership and where we're headed with that.
Thank you, Don. My name is Jim Matheson. I'm the Director of Sales for Oracle's ISV and OEM program here in the Midwest. As many of you know, we've had a great deal of success, but that success has really come in combination with a great relationship we've had with a number of our partners worldwide. About 18 months ago, we developed a relationship with IQware, and that relationship has really blossomed into something that is a very strong combination of Oracle technologies and the IQware technology that has really brought a very fulfilling and compelling story to the marketplace. But I'm just one half of the story here today from Oracle. It's my pleasure to introduce you to Jeff Davis, my technical counterpart.
Hello, I'm Jeff Davis. I'm a principal sales consultant with Oracle Corporation, and I'm responsible from a technical perspective for the relationship with IQware. Oracle Corporation is built upon these relationships with our partners who take their unique intellectual property and build it on top of Oracle technology. Like that advertising tagline, we don't make the tennis ball, we just make the tennis ball better. It's partners like IQware who build that property and make the products better all the way around. Now, I'm a technologist, and I can generally speak for hours about Oracle technology, but I won't today. Today, it's all about IQware, and it's my privilege to introduce the founder and CEO of IQware, Dr. Steve Belovich.
Good afternoon. Appreciate everyone taking the time out of their day to visit with us and enjoy this webinar. As you can tell from the slide, we are going to talk about cyber terrorism, among other things. And you'll notice the pictures on either side of it. Those are from World War II, and that's a couple of B-24 squadrons during the middle of a bombing run over occupied France and Germany. That was done, or taken from my dad's aircraft, as a matter of fact, and he was a student of that war, which allowed me to be here today to talk about the new war. I also want to thank Oracle for being here. Appreciate that. And again, thanks to my dad for studying B-24 bombardiering so I could study engineering and again be here today. What I'm first going to start with is a sit rep or situation rep, which I think most people are already familiar with. The war zone these days in cyberland is your facilities, whatever they may be. Any data source, any communication portals, any data transmission of any kind, any data transformation of any kind, any manually entered data. Anything that gets converted to electronic form is at risk. And of course, as you can see from the lower left-hand corner of that slide, once you're connected to the internet, you are essentially connected to the entire planet, whether you like to be or not. Now, the question that naturally arises for people is, am I a target? And if so, why? Well, there's a couple of things. First of all, you've got phishing. Phishing is when hackers are hungry. They want to get fish. They don't really care which fish they capture, but they cast a wide net, pick up a lot of fish. You could be in the net, you could be out of the net. It's a matter of the luck of the draw. But healthcare in particular, you are a target. And the reason why you're targeted is there's a lot of value in personal health information, electronic medical records, that it goes well beyond a simple Social Security number, a name, address, phone number, things like that. And of course, you can see the definitions on the slide there between terrorism, extortion, blackmail, and theft. Obviously, what happened to Sony was extortion, which is comply with my demands or else. Terrorism is simply a variation of that, where you're trying to generate fear, uncertainty, and doubt. Okay? But blackmail and extortion and the monetization thereof are becoming more prevalent in the world, and there's more people with the operational capability for doing these things than there ever used to be. back to PHI for a moment, personal health information. What makes that valuable is it's easy to recreate you digitally, anywhere, anyplace, anytime. That's why it's very dangerous for that stuff to get out. Once your credit card information gets out, you can get a new credit card. You can do, there's a stop loss, a lot of things that you can do to protect yourself there. With your health information, once those records are out, you cannot change your personal health history. If you had a certain operation or procedure done at a certain time, that's real. And once that information is out there, somebody has access to it, that can be used for ID theft. There's a little bit for the healthcare folks about HIPAA and meaningful use. I'm not going to cover much of that. Again, as Don pointed out, you can download it later. Suffice it to say, there are laws and rules and regulations that cover these things and cover the responsibilities of custodians of healthcare data and also the people who generate the healthcare data, which may not be the same organizations. Reality therapy. Everyone likes to claim, I am compliant with regulations or I'm compliant with the rules. That's great. That is helpful, but that will not stop a hack. It won't undo the damage. It will generally make the penalties, should there be any, less onerous. However, compliance alone will not keep you out of the courtroom. And that's on the picture on the lower right-hand corner of that slide. Court cases, and I've been involved in quite a few as an expert witness, can be very expensive, and if you do not provide or show that you have provided adequate protection, you're going to be liable. And a lot of companies are finding that out right now. Many cases are working their way through the legal system, and we do not have final adjudication on most of them. Now, your cyber war casualties. Everyone's heard the stories. Target, Memorial Health Systems, Community Health Partners, Home Depot, etc. Most recently, you had Anthem and Sony Pictures. And as I recall, there's been a recent hack just a day or two ago. These things are getting worse, and they're getting more insidious. And if you look down the casualty list, the question in your mind should be, who's next? Actually, the question should be, am I next? And the answer to that is, yes, you are. Gone are the days when you can say, I'm safe, I'm fine, I don't have a problem. You do, you have a risk exposure. It's non-zero. You can't assume that it's not there. Okay, a little bit of a background on what happened with Sony. All right, what happened with them? Well, Sony Pictures, they're a movie company. And as such, they have digital assets. And what does that mean? A set of frames, a set of pixels, some digitized film. And they distribute those because in making movies these days, you need to spread that out among a lot of people. Each group of people has a certain number of frames they have to deal with. So naturally, Sony has to allow access via the internet to its digital library. Risk point one. Risk point two is that, again, they're using the internet to do it, whose weak spot I'll show you in a momentarily. But that's the problem. Their basic architecture, excuse me, and their basic approach to how they're doing their business automatically makes them more vulnerable than would other stores, or like Home Depot, or like Anthem. But what did happen to Sony? In any event, they got hacked and they got extorted. And it was done by, suspected to be done or instigated by the North Koreans, but not actually performed by them because they lacked the operational capability. Although the FBI most recently has amended their statement that I have in the slide there, and they have confirmed it originated in North Korea, but not, the attack didn't, but the people who instigated did. But the key thing is that Sony has created a real risk because of how they do business and the deployment of critical assets that are accessible via the web. That's a big problem. And Sony's not the only company with that problem. So how did they break in? Well, there's a number of ways, but the first thing is some basic internet security fun facts. That's on the slide that you can see. TCP/IP is is a communication protocol used by the web. It was invented a long time ago. Came out of Dr. Leonard Kleinrock's original work at MIT and part of DARPA. It used to be called DARPANET, and through a series of transformations became what we now know as the Internet. This protocol was designed to make things easily connectable. It was not intended to make things secure. And the biggest flaw that it has, and this is a huge one, is it permits challenge and response without authentication. Challenge and response without authentication. What does that mean? It means I, as a potential hacker, could ask your network, your software systems, digital questions and get answers. And you never at any time are asking, who am I? Do I have authorization to ask those questions? Am I authorized to get that information? Not at all. That means I could do a silent probing of your network. Silent meaning your systems are not waking up. They don't know that I'm out there doing this. That's the really cool part if you're a hacker. And that's the problem. Now, some more basic fun facts. The initial connectivity was considered the key factor in the design of TCP/IP, as well as its ability to communicate with different devices. And somebody once suggested, well, gosh, why can't we just change that protocol, solve all the security problems? Number one, they wouldn't solve all of them, but that would solve a lot of them. Why can't you change the protocol? It is estimated that the installed base of TCP/IP compliant devices exceeds $3 trillion worldwide. Sheer economic inertia is going to prevent you from doing what needs to be done. And I guarantee you in 10 years, that's not going to happen. So we have to live with a protocol that has been built, designed, implemented in a variety of different ways, in a variety of different devices, and work within that framework. There we go. A little bit of security history. Part of understanding what the real problem is and the solution we'll present in a few moments depends upon your understanding of how we got here. We care about history because it explains how we got here. And if you don't really understand the problem and where the problem came in, your chances of getting a solution are effectively zero. All right, the early years, since ENIAC won in 1946, getting hardware working was a big issue, very important. Mainframes dominated. You didn't have any connectivity. Programming was manual. Security was simply not an issue. Later on, hardware became reliable back in the early 60s. Operating systems evolved. Networking was invented. And some basic security protocols were implemented. Username, password, things like that. But generally, if you didn't have the private number or physical access to the building or the system, security was not an issue. Not a problem. In the late 60s and early 70s, the operating systems became stable. Therefore, there were more of them, as before they were one-offs. And your growing installed base actually reduced the number of architectures. The marketplace in the 1960s could run a lot of experiments, right? Not a lot of installed base. You bought one machine, you can buy another one. After the 70s hit, there were a lot of functionality already thrown onto existing platforms. So as a salesperson going into that marketplace, you all of a sudden had to consider what the customer already had. And that made a difference. Now, what they invented was multi-task operating systems that required protection and multi-user operating systems to supporting user isolation as well. Task isolation and user isolation. Two key inventions. Very key. Now, later on in the 70s and 80s, you can read those on the slide. The key invention there was a secure system design was introduced by the U.S. Air Force back in 1972. I will cover that in a little bit. And then you had the PC desktop revolution, which started in 1980 and has continued onward. The operating systems invented there were started out simple and dumb because the hardware was cheap. Interestingly enough, inventions 1, 2, and 3 that I mentioned in these slides were omitted in the design of all PC operating systems. Deliberately omitted. Security was saying, we don't have the bandwidth for that, we don't have the hardware support for that, we don't have the RAM or disk space for that, we're not going to do it. Besides, who cares what's on a PC? It's for somebody's home. I bet they sing a different tune today. Nonetheless. Anyway, the operating system expanded to include what used to be applications. Before you had an operating system and anything else was an application. Now the operating system comes preloaded with games, toys, browsers, you name it. It's hard to think of something that's not part of the operating system today in 2015. And then, of course, you have a huge installed base and the widespread use of the internet. So what do we know now? The dirty little secret. Things that we've learned through security research. Well, in October 72, the U.S. Air Force commissioned the Anderson Report. And it was a study of how can we create a secure system design. Back in 1972, the Air Force realized that this mattered. This mattered a lot. And they had to do something. So they did come up with it. In April 74, a guy by the name of Barry Schrager, who I happen to know quite well, worked for IBM. He tried to implement that secure design at IBM. In some areas he succeeded, but he could not implement the full thing. Why? It has nothing to do with Barry's tremendous skill set. It had to do with the fact that IBM already had existing architectures sold to banks, sold to other organizations that were worth millions of dollars already, and they could not simply go to those customers and tell them, get rid of this architecture. Not possible. So he did what he could, but he had to maintain compatibility with what was there. An upstart company named Digital Equipment Corporation, founded by Ken Olsen, one of many successful MIT grads, said, hey, we're going from the 16-bit mini computers to a 32-bit mainframe. We want to compete with IBM, so we'll go and build that. So what happened? Compaq bought DEC, HP bought Compaq, and in 2011, the only transaction operating system that's never been successfully hacked, when properly configured, is OVMS. Very recently, in August 2014, a new company was created called VMS Software, funded heavily by a variety of groups, and they are now taking that software to the next level of development, which I believe is going to be good for the entire industry. Now, that architecture, what makes it secure is that it includes the structure that you see in the slide. You do want to take a look at that. At the lowest level of the operating system, the reference monitor adjudicates the access of any subject to any object. And any subject could be an active entity, a process, anything that needs to gain access to data. An object is a file, a directory, any kind of passive data repository. There's an authorization database which lists who's allowed, when they're allowed, how they're allowed. So all that's controlled. And there's an audit trail so you can keep track of who's trying to get to what. That is included at the very core, lowest level of the operating system, right above the first level interrupt handler. That is essential for security. If the operating system does not have that structure, guys like me can hack it. Guys better than me can hack it more rapidly. And things on that system are at risk. Now, we've covered the problem, and in previous presentations I've covered the problem far more in depth. What I want to focus on is the solution. What do we do about this? All right, some basic concepts. We need to take a step back and really look at what we're trying to do here. First of all, can I protect my network 100%? No. We've already answered that question. The protocol TCP/IP has built-in security flaws. So no matter what you do to it, you cannot unring that bell. You cannot protect that because it's not designed for that. Unless you rewrite it, in which case you'd be incompatible with everybody. Can I make my existing software system secure? Answer is no. Again, because they're built on top of a platform that is itself not secure. Now, ladies and gentlemen, think about it. How much time and money have you or your organization spent on trying to attempt the impossible? That should bother you. It should bother your CIO, and sure as heck should bother your shareholders. I know I'd be bothered by it. That's basic concept number one. Now, clearly, what we're doing now as an industry isn't working. If it were, there'd be no need for me to stand here and explain security issues. No need for this webinar whatsoever. And there's no way to make it work the way that people are trying to. Defense in depth, net-centric defense, better firewalls, better access control lists. That's all good. Antivirus software, please don't stop doing that. But to think that that's going to be a solution is to not be thinking correctly. What we need is to rethink the entire situation. And this next slide you really want to study because it's going to prove to be the hardest slide to understand in the entire presentation. That's the one. We're starting with a clean sheet of paper and making room for new concepts. And I want to take a moment to point out three kinds of ideas on this slide that are obviously not visible deliberately. Idea of type 1 is an idea that solves a problem. People have been looking for that, the holy grail, the ideal firewall. Idea number 2, category number 2, would be ideas that prevent problems. Those are even better. Those are certainly helpful. But we've tried both of those in this industry, and they're not working. What we need are what we call category 3 ideas. That's where IQware comes in. A Category 3 idea is an idea that opens up a new doorway for you, creates new possibilities, creates a way out of the box that you're in. That's what we're going to talk about. And that's what we need to allow room for. Okay, new ideas. Why do we need them? The old ones don't work. If they worked, we'd be using them. Why does software stink? Costs too much? Takes too long to create it. The customer hates it. Everyone knows that. Now, what is innovation? You want to take a look at this a little bit. It's creating new possibilities and opening new markets using invention. Invention is not innovation. Invention is a necessary component to innovation. Invention by itself is not. You have to apply it to create a new possibility or open up a new market. And sadly, innovation is not understood very well. It's often ignored in companies. And the bigger the company, sometimes the more it's ignored, just due to human nature. Cybersecurity. All right, let's break that down to something very simple. What is it? Only authorized people can use your stuff. How you authorize them is up to you, but you want to make sure that only authorized people can do it. And number two, and more importantly, you always want to guarantee system operation even in the presence of bad stuff. Evil network packets, hackers, whatever, right? Errors in hardware, errors in coding, errors in whatever. You want to guarantee that your systems will still function and function properly. That second one's a harder one. So what's your box? Your box as an IT person is that what you're doing now is the same thing your grandfather did or grandmother. You are writing code. You're fingering at a keyboard, moving the mouse, generating executable images, binaries, distributing those, designing modules, module-based design, dealing with stack issues. You're dealing with module layout issues, data types, all those kinds of things. What is different between today and 40 or 50 years ago? I'm looking hard. I don't see much. The tools you're working with are better, kind of like a carpenter. You're pounding with hammers, and the nails are glow in the dark blue, and the wood's got this neat velvety touch, but you are pounding nails into wood. And guess what? You're building the same kind of structures you used to build. So the only way to get out of that box is to question all assumptions, not just some of them. I threw one out there. Like, do you even need programmers? What for? Maybe we need to be thinking about that. So that's the level of questioning we need to do, and that we are doing right here. Okay, some useful ideas from diverse fields. You've got language, DNA, and numbers. Seems kind of weird for a cybersecurity presentation. Why would I bring that up? Well, simply that. Language, in our alphabet, we've got 26 letters. DNA, we have 4 base pairs. Numbers, we've got digits 0 through 9. Each one of those things can create an infinite number of combinations. We've never run out of books, movies, people, or numbers we can represent. That's very interesting and very, very powerful. That means from a finite set of objects, I can create an infinite set of possibilities, possible arrangements. So, okay, let's segue back to software apps for a moment. What do we need for a software app? Well, what does it really consist of? If I'm asking a programmer, he's going to say, well, code. Notice I'm not going to use that word. That's a bad word. It's a 4-letter word for a reason. Workflow, data flow, and user experience. Those are the 3 things that matter for an app. Those are 3 things that when you develop code, you are paying for, because at the end of the day, it's not the app that you want. It's what's the app going to deliver to you. What will it do for you? That's what you care about. That's what the budget's for. That's what the time and energy are for. So we need to focus on that. So here's an idea, a bit of a radical approach. Why not we stop writing code? We've been doing it for 50 or 60 years, still costing us money, still testing and debugging. No one likes it. And if you admit you wrote the code somebody doesn't like, you're probably in fear for your life. So we create a new symbol set. Not going to explain how at this point, but let's just assume that we can. And then we graphically configure that to become the app. That's kind of skipping a lot of the programming steps. Now, something to think about. At least we might be solving the merry-go-round of code, compile, test, debug. That's advantage right there. So let's make it even cooler than that. Let's use a symbol set to create what we want or to talk to the machine. Let's put that on top of the secure operating system already designed and built and available and proven using the United States Air Force's model, and then make the whole thing configurable. So the equation now becomes configuration plus that symbol set plus your secure operating system equals your app. Whereas before, the configuration would be money, time, programmers, modules, linked lists, etc. It becomes your app. Now let's go back to how can we actually do that? Now we've got the concepts fleshed out. How can we make that happen? Well, first of all, the right way to do things is obviously put things on a secure platform. Let's start with that. Without the secure platform, you cannot make it secure. You can make it difficult for hackers to break in, but determined hackers have been extraordinarily successful at breaking through even the best net-centric defense, and we're reading about more of those every day. Now, what we've done at IQware, and what's patented, is what you see in this slide. You want to take your time with this one. We have broken the app into two areas, one of which sits on the client piece. That client piece could be a mobile phone, a personal computer, or any type of laptop, desktop, palm top, whatever. The heavy lifting of the application, the part that does all the work, is in the right-hand and lower portions, lower right-hand corner of that box that's outlined in green. That's the business logic, the user input, the program state, any other conditions, and then the program response, and your routines that need to be executed. And then the lower left-hand corner is the idle time, where the system is waiting for another user input. So the only part, and that's in blue, that is resting on a handheld or mobile or any other device that is not secure is something that handles user input and also does rendering. Rendering means drawing. It means making a polygon of some sort, filling it with color. So you can see, in effect, we've kind of turned the system into a bit of the 1970s, 1960s mainframe dumb terminal model, which isn't a bad thing because we didn't have a whole lot of hacking trouble back then. The hacks you had were all inside jobs, and they were all preventable by proper personnel procedures. Today, as I mentioned in my first slide, you are connected to the entire globe through the internet. Now a lot of people can access it. Now the third invention is taking those two parts of that slide that you see, the business logic and the programming response, and make that controlled by rules, a non-traditional use of a rule-based design. That was a rather difficult invention to come up with, and that's where that symbol set that I described comes up, is relevant here, because we figured out a way to generate a new symbol set that would indeed implement business logic, implement workflow, data flow, define and examine program state, and execute various routines that you need. That's the key part. Now, the rules control all aspects of operation of our system. All aspects, not just some. The visuals that you see, the screens, the transitions, again, workflow, data flow, user experience, colors, any type of data entry devices, all of that stuff. They can be changed on the fly, changed while the system is running, and there's no limit to the combinations of things that those rules can create. So what does that mean? That means whatever software functionality you as a customer would need, this rule set is sufficient to generate that level of functionality. Very important to note that. That's a key part of the design, and that's what, again, is patented. And what this leads to are a couple of very significant paradigm shifts. And this slide, again, is worth studying for a bit. Paradigm shift is, number one, we've changed the software design process. It starts in your brain, on the left-hand side there. You create a data flow and a workflow, a user experience that you want to achieve. You can draw those out, map them out, use whatever tools you like to express those. Once you do, we translate that into rules. Rules are defined as, upon an action, do an event. You also have a data source and a data destination, and various other parameters, and that defines the rule. The collection of that set of rules, when applied to our rule processor, which you can see on the screen, connected to the Oracle database, all of it operating on top of a secure, trusted computing base, that's what TCB is for, that is now your application. So paradigm shift number one, our patented rule data structure, event action. Upon event, do an action. All right? Paradigm shift number 2, the change in the development process. Notice we're not mentioning the coding of modules anymore. Kind of like a kid's bag of alphabet blocks. You have a bag of blocks with the letters A through Z. You can arrange them to spell any letter you want. You spell cat, it'll meow and drink milk. You spell dog, it'll bark and bite the mailman. Might even fetch the newspaper. The point is, same set of blocks, simply rearranged. That's part of it. The third paradigm shift is your app structure and deployment. What becomes your app? The platform, the Oracle database, our rule processor, and the set of rules that are in the green cylinder that you see. That set of rules contains the knowledge that you have either developed or had us develop for your data flow, workflow, and user experience. 3 paradigm shifts, all protecting intellectual property, all implemented, and obviously deployed. Now, if you were to deploy this in various different situations, this is another slide that you want to take a look at. Everyone has existing IT systems. Those are indicated by the gray oval in that slide. And those IT systems may talk to various databases, which are those yellow-orange cylinders in that slide. Okay? We can connect to those via a direct connection, and assuming there's no other ingress or egress, this would be a reasonably secure way to deploy what we have without overly disturbing what already exists. And of course, we add our own databases to that as part of implementing the desired workflow, user experience, and data flow, and then we would distribute that, the user portion, or the client piece rather, through the network to the various terminals that you see in that slide. Again, it's a secure architecture and allows an integration. A more detailed look at that is the following slide. What you see at the top, those 3 gray circles, are existing functions that your IT systems do right now. They do them today. Functions 1, 2, and 3. What we normally can do for you, and the best, our preferred approach, is to add functions 4 and 5, which are functions that your IT system is not doing right now. So we're bringing something new to the table for you. Now, we're also showing on the left-hand side that gray circle with the down arrow going into our rule-based system. What that is indicative of is we can take the user experience, the data flow and the workflow that you've developed and spent the time and money to refine in your function number 1, whatever it may be. It might be a patient record handling system, clinical decision support. It might be a wastewater control system, anything. And we convert that to our rules and therefore bring it into our secure architecture. That's not a requirement for deployment of what we do, but it's an example of how you can preserve your existing IT investment by bringing it into what we do. And then, of course, those other functions, items 2 and 3, the same process. So what we presented here is a game changer. It's got significant transformational value. First of all, we have come up with a new way of describing your app, your concept of it, to the computer. A new way of getting the computer to do it that does not involve conventional programming or module-based design, module-based creation, and all the pitfalls that are present with that process. We skip that costly step. We also avoid any errors that come across with module development, as any person trying to do a build on a complex system realizes can crop up at any time. And we deliver functionality by a very simple formula, which if you get nothing else from this presentation, you get this, I feel I've done my job. IQware, our stuff, plus the rules, plus Oracle, plus our trusted computing base, equals your secure application. And how you preserve your existing investment is, if you take a look at that slide in the lower left-hand corner, your software functionality in terms of your user experience, your data flow, and your workflow, they go into our rule set, which was represented by the canister on a couple slides ago. That is preserving your investment. Typically, at least 60% of the cost that you've spent developing apps has to do with that user experience, workflow, and data flow. 40% is typically on the coding. So it is possible to take the functionality you need either for internal operations or that you wish to remarket to your customer base and bring it into our secure architecture, preserving the bulk of what you've already spent. And that's how you do it. That has transformational value, and that's a game changer. Basically sum up, using this method, the IQware way of doing things, you can develop software for 1/4 the cost, 1/5 the time. You have the security end of it, and you've got compatibility with all kinds of handheld devices. I know a lot of people are getting killed financially right now trying to keep up with a plethora of mobile devices. They have to write a custom app for every single one. Because our client is ultra thin, we use MIT's XLib, we don't have that problem either. And that's kind of nice. And it's been a heck of an advantage for our deployment. We can use the latest technologies, again, and not worry about what's coming down the pike. We can deal with that. And we can allow you, the customer, to use an SaaS, Software as a Service deployment model, maximizing revenue and tailoring your revenue stream to each individual customer, and even on a per customer or per user basis. That's how fine a granularity we can customize that using our rule base. But that basically wraps up what I have to present. And I imagine there'll be some questions.
Yeah, Steve, we have some questions from some of the viewers. First question is this solution appropriate for a cloud deployment?
Good question, and rather timely. The answer would be yes. Cloud deployments are becoming pretty much the vogue, and there's a great need for accessing those objects in the cloud, integrating them in a simple, coherent way that's very flexible, secure, and then allowing the presentation of that combined functionality onto mobile, handheld, desktop devices, again, without compromising security. What we have is an ideal platform for doing so.
Okay. Another question came through. Can we still use a browser utilizing the IQ architecture?
It is possible. One of our rules does allow for the invocation of a browser by a remote procedure call, and we can feed it URLs and other information. Of course, that browser will operate under the aegis of your handheld or desktop device. So the browser itself cannot be made secure in that manner, and anybody having or beginning to access data that way is going to be at risk. We can't control that. That's a function of the platform they're using, the browser they're using, and the data that they choose to allow the browser to access.
Another question you kind of covered earlier in your presentation, but they're asking, can we take advantage of the IQ architecture with our existing systems?
Yeah, I kind of referred to that, but again, the answer is yes, you can. You can preserve the bulk of your investment simply by translating what you've already built in terms of user experience, workflow, and data flow into our rule set and applying that rule set to our rule processor. That will give your app, and not only give the security, but give you the flexibility of the mobile deployment world and whatever mobile device may be invented 2, 3, 4, 5 years down the road.
A final question, Steve, in the time frame we have is kind of a wide open question. Is anybody really doing this today?
Yeah, absolutely. The American Pharmacy Association Foundation is using it as their main data bucket. The Alliance for Patient Medication Safety, another national organization, is using it. We recently got a contract through the Tennessee Pharmacy Association for handling the Center for Disease Control pilot program with some MTM and some disease state management functions. Those are just to name 4. I want to thank everybody for the time and the attention. Appreciate that. And this, as Don mentioned, you'll be able to download both the presentation slides and view the audio and video on the web within a short period of time.
I'd like to introduce Mark Ricker, Chief Marketing Officer of IQware Solutions, just for some closing remarks and to wrap the presentation up.
Hi, I'm Mark Ricker. I appreciate, or we all appreciate you coming or taking your time today to learn more about IQware. Steve hit you with a lot of information, and because it's a paradigm switch and something that is totally different to a lot of people in the way we do things, I hope that you'll go onto our site and download the information that Steve presented today. There's other information on there as well. A couple things I'd like you to take away is that we talked about the interoperability. and the opportunity with our rule set to basically accept data the way any source is designed to push it by simply writing a rule, and to push data to any source the way that source is already designed to receive it by, again, writing any rule. Steve's development team, headed up by Steve, has been working on this for a long time, and it's successful. I don't think Oracle at this point would be dancing with us if it hasn't been proven, and they see an opportunity in the future. So with that, I will turn it over to, I guess that's it for us. Thank you very much for your time today. Again, if you have any questions, please look on the slide that is in front of you right now. Send your information, and good day.